Chapter 15, Mass Wasting. The importance of mass wasting. Landslides as geologic hazards. A landslide is a sudden event where large quantities of rock move downhill. When people and communities are in the way, a natural disaster may result. Mass wasting refers to the downslope movement of rock, regolith, and soil under the direct influence of gravity. The role of mass wasting in landform development. Geologic processes that often follows weathering. Sediment is ultimately transported to the sea. Combined effects of mass wasting and running water produce stream valleys. Okay, so excavating the Grand Canyon. So the Grand Canyon, originally all these rock layers were one solid rock layer. Okay, and the center here, this is the portion that was eroded by the running water of the Colorado River. The rest of it was debris that broke away through mass wasting. Slope changes through time. Most rapid and spectacular mass wasting events occur in areas of rugged, geologically young mountains. Mass wasting and erosional processes slowly change these rugged mountains to more subdued terrain. The role of water. When sediment pores filled with water, cohesion among particles are destroyed. Water can lubricate materials. Water adds weight to the mass of the material. For example, the La Conquista landslide. So here we have, let's say we have dry sand. Okay, you can't really build a sandcastle with dry sand, and the sand grains don't stick together. Add a little bit of water, and then you can build your sandcastle. But if you add too much water, that sandcastle will basically melt away. Okay, because the saturation reduces the friction and causes the sand to flow. Okay, so heavy rains can trigger a debris flow. So here's a scar caused by a 1995 landslide. The road down here is wiped out by all this material that flowed downslope, covered the roadway. Okay, and there was a second landslide, 2005. The debris flow went all the way into the town. Houses were buried in the mud and debris. The thick debris moved into some houses instead of flowing around them. Okay. Over steepened slopes. Unconsolidated granular particles assume a stable slope at what's called the angle of repose. So that stable slope, the steepest angle that the materials don't just start going downhill, is your angle of repose, and it's different for various materials. Oversteepened slopes are unstable and can trigger mass wasting. It's natural processes such as stream cuts can oversteepen a slope. Okay, so here for this particular material being piled up by this mine, this is its angle of repose. Okay, so if the side got any steeper, you might have some mass wasting. So here, as sand accumulates along dune crust, the slope gets steeper. Eventually, some of it starts to slide down. Okay. Here we have an oversteepened hill slope that was cut back to build this house, and if you have extensive rain, well, then you might have some instability and some mass wasting occur, and it could destroy your house. Removal of vegetation. Plants bind the soil and regolith together in addition to shielding the soil surface from raindrop impacts. If vegetation is removed by forest fires or by humans, timber, farming, and development, examples are Meton, France, Storm King Mountain, Colorado, then that may trigger mass wasting. Earthquakes and dislodged rocks and consolidated materials. Examples from California and China. The 1994 Northridge earthquake in California triggered 11,000 landslides. The 2008 earthquake in China caused landslides that created temporary dams and earthquake-created lakes. So here is earthquakes as triggers. So here is an example of a landslide caused by earthquake. Liquefaction. During periods of ground shaking, water-saturated surface materials behave like fluid masses that flow. So the ground surface turns to liquid and flows. Landslides without triggers. Well, slope material weakens over time. Some landslides are just random, unpredictable events. Here's some liquefaction underneath this asphalt. This parking lot was probably a clay material with some fluid in it, and then with the earthquake and shaking, it just liquefied, started to flow, leaving a void that allowed this car to break through that asphalt. Types of material. There's debris, mud, and earth are used. Those terms are used if soil and regolith move. Rock is used if bedrock moves. So type of motion of falls, the free fall of detached pieces is called a fall. Talus slopes are built up by rockfall. So at the base of a cliff you may have a whole bunch of chunks of rock built up at the base. That's called talus slope. So here in this rugged mountain, chunks of rock have fallen, have built up these fan shapes. These are talus slopes. Okay. A slide occurs when a distinct zone of weakness separates the slide material from the underlying material. A rotational slide, the surface of the rupture is concave up. A translational slide, the material moves along a flat surface. A flow occurs when material moves downslope as a viscous fluid. Okay, rates of movement, fast. A rock avalanche is the most rapid type of mass wasting. Rocks float on air as they move downslope. Slow, creep moves particles a few millimeters a year. Okay, so avalanche versus creep. Okay, here watch out for rockfall. The sign means watch out for rockfall. So along this road, yeah, there was some massive rockfall here. A slump is the movement of massive rock or unconsolidated material as a unit along a curved surface. It can involve a single mass or multiple blocks. It occurs along oversteepened slopes. So here the slope's been oversteepened, and the material just slumps down multiple blocks, and here's an earth flow at the base. Okay, slump at Point Fermia in California. So here's where it broke. That's where the material just slumped down. A rock slide occurs when blocks of bedrock slide down a slope. A debris slide occurs when unconsolidated material slides down a slope. Generally very fast and destructive, sometimes triggered by earthquakes, sometimes triggered by melting snow or rain, most common during spring. Okay, here's a rock slide. It's the surface of the rupture. So, the bedrock, these chunks of rock slid down the slope and covered this road. A debris flow is a rapid form of mass wasting that involves flow of soil and regolith with water. A mud flow if the material is fine grained, often confined to channels and canyons. Okay, so here down this rain channel, we have debris flow that flow down. Okay, this material is very fine grained. If it's very fine mud flow, and this is all mud flow material, came down slope. Debris flows in semi-arid regions. Sudden rainfall or snowmelt washes large quantities of sediment to rivers. Lack of vegetation to anchor the soil causes this. A lahar is a debris flow composed mostly of volcanic materials. There's a massive lahar flow during the eruption of Mount St. Helens. Here's a lahar flow from Mount St. Helens. So here it's going to be fairly deep. It was like maybe 5 feet deep there. Earth flows form on hillsides in humid regions during heavy precipitation or snowmelt. It commonly involve materials rich in clay and silt. So here along this slope we have earth flow. There's a lot of water and rainfall, and it kind of breaks away and just basically just flows gently down slopes such that it doesn't even break the sod on the top. Creep is a gradual movement of soil and regolith downhill, aided by alternating expansion and contraction of surface material. It causes fences and utility walls to tilt. So creep, so let's say we have a freeze-thaw process. Okay, so as moisture in the soil freezes, the soil expands. Okay, this particle moves up. As it thaws, as it falls back in place, gravity's going to pull on it. So it comes forward, and then the soil freezes. So over time, the material very slowly travels downhill. Okay. Let's see, effects of creep. Well, the rock layers start kind of like these bent rock layers, so you actually see how the debris is being moved slowly downhill. Like debris from this layer is now over on top of this layer. Okay, so you see trees start trying to readjust the direction of growth. Fences get tilted. Okay, retaining wall tilts and breaks. There's tension cracks in the asphalt. Solifluction is the downslope movement of waterlogged soils, promoted by dense clay hardpan or impermeable bedrock layer. Okay, and then all of the moisture groups above that impermeable layer. It's common in regions underlain by permafrost. Okay, so permafrost, especially like in Alaska, places where the soil is permanently frozen, it's full of moisture. Okay, and then but in some areas where that permafrost thaws in the summer, then it'll start traveling down slope. Okay, forming these like lobe-like shapes in the overlaying grasses. With global climate change, there's some warming in Alaska, so there's more permafrost is thawing out in the summers, causing problems. So permafrost is permanently frozen ground. Summers are too short and cool to melt the ice below the shallow surface. Deeper ground remains below 0 degrees Celsius throughout the year. Extensive around the Arctic Ocean, land use is regulated to prevent permafrost from melting. Okay, so let's say you built your house on permafrost, and the heat from your house in winter may thaw some of that soil, and then it'll cause subsidence. It's not very healthy for